Network management. In this video, we are going to see about network management. Network management in general is a set of activities where a variety of tools, applications, and devices are utilized by IT personnel to monitor and maintain information technology networks. Network management means different things to different people. There are no two identical network architectures, and similarly, all network management systems are different. The network administrator has to strike the right balance between the types of service offered to users, the quality of these services, and the means that must be developed in order to achieve the requisite level of quality. A network service is a product that is consumed by the user or client who enjoy the right and fulfills the obligations stipulated by the terms of service provision. It is the client's obligation to pay the bills due for the service and to dutifully respect all security procedures. From the user's perspective, the architecture, the workings, and the management of the network must remain completely transparent. In accordance with their conditions of subscription, users are quite entitled to expect immediate connection at any time of the day or night and at any time of the year. The network must meet their needs by providing reliable transmission of information with no loss or additional errors and with a satisfactory response time. Delivery of service must not be subject to any conditions, and the system designed to invoice usage of network resources must provide users with adequate billing information. Any network management system must manage and monitor the network irrespective of the network's architecture and complexity in such a way that the needs of users and operators alike are fully satisfied. The services provided by the network management include all and every function required to keep the network operational. Network management architecture. In this video, we are going to see about network management architecture. The architecture of a network management platform is made up of a common set relationships and structure that exist between managed devices and a management entity. The following list details the components found in a network: end stations, management entities, end stations, computer systems and network devices with software that enables the sending of alerts to management entities when network issues are identified, management entities. These entities are programmed to react to end station alerts by executing a predefined set of actions such as the following: event logging, system shutdown, console notification, automatic attempt to repair the system such as reload or reboot. The elements of a management system are as follows: network manager agents, network manager applications, network manager agents integrated with network devices, platforms, and applications. Network manager applications. Network management servers that collect network management data from the network manager agents and correlate the data for analysis by the network administrator or manager. Agent information is conveyed to the management entity within the network management system NMIS via a network management protocol such as Simple Network Management Protocol (SNMP). Network management applications. Network-oriented management applications can be divided in several major types according to the networks they cover: Wide Area Network WAN, Local Area Network LAN, Metropolitan Area Network MAN, Customer Premises Equipment. Although management applications may support several network topologies, for convenience of analysis, network management applications can be seen as falling in one of these major categories. The emergence of new technologies and services such as asynchronous transmission mode (ATM), synchronous optical network (SONET), integrated services digital network (ISDN), switched multi-megabit digital network (SMDS), common channel signaling or signaling systems 7, CCS or SS7, etc. Management standards. In this video, we are going to see about management standards. There are several network management standards that are in use today. The first four are OSI model, Internet model, TMN, IEEE LAN or MAN. The following table lists 4 standards along with the 5th class based on emerging technologies and their salient points. Standard salient points. OSI or CMIP. International Standard ISO or OSI, Management of Data Communications Network LAN and WAN, deals with 7 layers, most complete, object-oriented, well-structured and layered, consumes lot resource in implementation. SNMP or Internet. Industry Standard IETF, originally intended for management of Internet components, currently adopted for WAN and telecommunication systems. Easy to implement, most widely implemented. TMN, International Standard ITU-T, Management of Telecommunications Network, based on OSI Network Management Framework, addresses both network and administrative aspects of management. ETOM, Industry Standard for Business Processes for implementing TMN using NGOS's framework. IEEE standards adopted internationally, addresses LAN and MAN management, adopts OSI standards significantly, deals with first 2 layers of OSI RM. Emerging technologies. Web-based Enterprise Management WBEM, Java Management Extension JMX, XML-based Network Management, CORBA-based Network Management. Stages of network management. All areas of network management follow roughly 4 basic stages. They are as follows: policy formulation, monitoring, analysis, control. Policy formulation. This defines the normal operating conditions and expectations for the network. Monitoring. Monitoring collects the status of the network to see if it follows the policies formulated above. Analysis. Analysis determines whether the network is operating correctly or not. If network is not working properly, it determines the cause of the problem and finds what should be done to correct the situation. Control. This phase implements the action plans from the analysis stage to correct the behavior of the network. Management models. The OSI network model is an ISO standard and is most complete of all the models. It is structured and it addresses all aspects of management. An OSI network management architectural model that comprises 4 models. They are organization model, information model, communication model, functional model. Although the above classification is based on the OSI architectural model and its parts are applicable to other models, it helps us understand the holistic picture of different aspects of network management. Organizational model. The organization model describes the components of network management such as a manager, agent, and so on, and their relationships. The implementation of these components leads to different type of architectures. They are two-tier model, three-tier model, manager of managers, peer NMS. A network object called as network element consists of hosts, hubs, bridges, routers, etc. Network objects are classified as managed and unmanaged elements or objects. The managed objects have a management process running in them called agent. Unmanaged objects do not have agent running in them. The manager communicates with the agent in the managed object. Information model. Information model is concerned with the structure and storage of information. A book is identified by an International Standard Book Number (ISBN). It is a 10-digit number that identifies the author and edition of the book. A figure in a book is uniquely identified by ISBN, chapter, and figure number in that hierarchical order. For example, ISBN 013437708 refers to the 3 of the book James F. Kurose and Keith W. Ross, Computer Networking, a top-down approach featuring the Internet, Peers in Education. Thus, a hierarchy designation ID, ISBN, chapter, figure number uniquely identifies the object which is a figure in the book. Here, ISBN, chapter, figure number define the syntax, that is a format of the information associated with a figure, and their meanings in the dictionary would be the semantics associated with them. The representation of the objects and information relevant to their management forms the management information model. Communication model. The communication model deals with how the management data is communicated between the agent and manager process. It is concerned with the transport protocol, the application protocol, and commands and responses between peers. The applications in the manager module initiate requests to the agent in the Internet model. It is a part of the operations in the OSI model. The agent executes the request on the network element, that is managed object, and returns responses to the manager. The notifications or traps are the unsolicited messages such as alarms generated by agent. Functional model. The functional model addresses the network management applications that reside upon the Network Management Station (NMIS). ISO has contributed a great deal to network standardization. Their network management model is the primary means for understanding the major functions of network management systems. This model consists of 5 conceptual areas. They are configuration management, fault management, performance management, security management, accounting management. Configuration management. In this video, we are going to see about configuration management. Configuration management is a set of activities aimed at discovering and documenting information about all network and system devices, highlighting changes and deviations from predefined standards or baselines, and reporting on the status of the network at any given time. The configuration is composed of all the hardware, software, interfaces, and communication circuits associated with network and system devices, local and distributed. Networks are continually adjusted when devices are added, removed, reconfigured, or updated. These changes may be intentional, such as adding a new server to the network, or path-related, such as a fiber cut between 2 devices, resulting in a rerouted path. If a network is to be turned off, then a graceful shutdown in a prescribed sequence is performed as part of the configuration management process. The process of configuration management involves identifying the network components and their connections, collecting each device's configuration information, and defining the relationship between network components. In order to perform these tasks, the network manager needs topological information about the network, device configuration information, and control of the network component. It provides the means for central storage of information about the devices and therefore forms the basis for fault, security, performance, and accounting management. It is absolutely crucial in providing high availability networks and system environments. Basic functions of configuration management are installing the physical equipment and logical configurations, job initiation, tracking, and execution, resource initialization, network provisioning, resource shutdown, backup and restore, service planning, auto discovery, configuration database and reports. In this video, we are going to see about configuration database and reports. Configuration database. A configuration management database (CMDB) is a database that contains all relevant information about the components of the information system used in an organization IT services and the relationships between those components. A CMDB provides an organized view of data and a means of examining that data from any desired perspective. Within this context, components of an information system are referred to as configuration items (CI). A CI can be any conceivable IT component including software, hardware, documentation, and personnel, as well as any combination of them. The processes of configuration management seek to specify, control, and track configuration items and any changes made to them in a comprehensive and systematic fashion. The IT Infrastructure Library (ITIL) practices best standards including specifications for configuration management. According to ITIL specifications, the four major tasks of configuration management are identification of configuration items to be included in the CMDB, control of data to ensure that it can only be changed by authorized individuals, status maintenance, which involves ensuring that current status of any CI is consistently recorded and kept updated, verification through audits and reviews of the data to ensure that it is accurate. Configuration reports. Configuration management (CM) is a data-centric process that can help to generate many types of reports. For example, simple inventories, exception reports, reports broken down by business units, and dependency reports. Most of these reports should be defined and configured as a part of the day-to-day reporting requirements. However, management may need new reports to make decisions. The following steps are good practice to follow to satisfy any reporting request. Analyze reporting requirements. Define and build the report. Generate and communicate reports. Analyze reporting requirements. Analyze reporting requirements. Determine whether the reporting requirements, including content, frequency, and media, are compatible with the configuration management model. If this is not the case, a customization to the existing reporting structure is required. Define and build the report. If the report does not exist in the CM model, the new report has to be defined and built according to the requirements. This entails a change in the CM model. Generate and communicate reports. Generate and communicate reports. Produce the report and format the data according to the identified requirements and communicate and disseminate the report to all stakeholders. Following are the examples specifically reporting requirements. Identify status changes of configuration items CIs and report against the baseline. Match all configuration changes with approved requests for change to identify any unauthorized changes. Report the unauthorized change to the Change Management Authority. Establish a procedure to add newly identified stakeholders to the distribution list of standard reports. Fault management. In this video, we are going to see about fault management. Network fault management, a key part of the today network management architecture, covers functions such as detect, isolate, resolution, and reporting of various malfunctions in a network. Faults typically manifest themselves as transmission errors or failures in the equipment or interface. Faults result in unexpected downtime, performance degradation, and loss of data. Generally, fault conditions need to be resolved as quickly as possible. The objectives of doing fault management are to increase network availability, reduce network downtime, and restore network failure quickly. Fault management consists of the following functions: monitoring and collective statistics on network devices, traffic conditions, and usage in real time to avoid and forecast potential faults. Setting thresholds and alarms that may cause network failure to warn the network admin. Setting alarms that warns of performance degradation on network devices and links. Setting alarms of network resource such as hard disk space, usage, and limitation problems. Remotely control network devices for rebooting, shutting down, etc. A typical fault management system follows these steps. When an error occurs, a report is generated and is sent to the fault analyzer. The fault analyzer diagnoses and records the problem. Finally, a system or a person uses the information from the fault analyzer to take appropriate actions such as isolating the error, blacklisting failing or failed components, automatically restarting or restoring services, and alerting the system administrator. Identification and isolation. In this video, we are going to see about identification and isolation. Fault diagnosis is the term that encompasses of two fault management FM functions of fault isolation, fault identification. It can be considered as a composite function that aims to determine the location and mechanism of the underlying failure causes. Both fault isolation and identification are measured via ambiguity groups, which are groupings of components that cannot be distinguished from each other based on the detection signature provided by the failure detection and/or anomaly detection functions. If a specific set of failure detections or anomaly detection occurs, there are several possible components in which the underlying failure cause may exist, and it is not possible to determine which component among the set contains the causal mechanism. Fault isolation. Fault isolation attempts to answer the question of where the causal mechanism of an off-nominal state exists. The FM usage of the phrase fault isolation as a diagnostic function should not be confused with the use of the same phrase to describe a mechanism to prevent failure effects or causal mechanisms spreading from one location to another. This usage is common in electrical applications and electrical engineering. Fault isolation function determines the location not just of faults, cause of failure inside the boundary, but also environmental failure causes. So, it would be somewhat better termed failure cause isolation through, for historical reasons, people hold to the commonly used term fault isolation. Fault identification. Fault identification, sometimes called fault characterization, attempts to answer the questions of what the causal mechanism of an off-nominal state is. Its implementation sometimes operates similarly to the fault isolation function in that automated diagnosis tools use similar techniques of forward and backward tracing of failure effects to determine the location of the faults as it does to determine the possible failure modes that cause the off-nominal state. However, fault identification is frequently implemented quite differently than fault isolation, with humans performing tailored analysis to determine off-nominal behavior causes. Protecting sensitive information. In this video, we are going to see about protecting sensitive information. Security management is a process to control the access to network resources according to local guidelines so that the network cannot be sabotaged and sensitive information cannot be accessed by users lacking appropriate authorization. Security management deals with two sets of actions. The first is aimed at denying access to sensitive information or resources by unauthorized users. The second is preventing malicious events or actions that will lead to access being denied to authorized users, that is denial of service or DOS. Resources to prevent security breaches are as follows. Firewalls, for example, packet filtering using a TCP or UDP port address. Cryptography, that is encryption. Authentication, example, data integrity and data origin. Authorization, for example, read, read-write, no access. Basic functions of security management are selective resource access, access logs, data privacy, user access rights checking, security audit trail log, security alarm or event reporting, take care of security breaches and attempts. Keep personal and financial information out of reach from thieves. User must keep it to themselves. Unfortunately, it is not so easy to do. There are a number of clever ways cybercriminals have devised to snare their information before they realize it. Protect passwords. Don't share information on a website, in an email, or over the phone. Create passwords that are at least 8 characters long and use a combination of numbers, letters, and symbols. Avoid common words. Cyber thieves can quickly try every word in the dictionary to guess a user's password. Avoid unsecured Wi-Fi networks. Try to use secure wireless networks. On a public wireless network that anyone can use, user may be at risk if they visit banking or other websites that require sensitive personal information. If user have a wireless router at home, turn on the encryption feature and change the identifier, that is network name and administration password, from the default. Don't get scammed. Never respond to phone calls, text messages or emails soliciting personal information even if it is from someone user think they know. If you suspect the request is legitimate, call the person or entity to confirm the validity of the request before they share. If user would like to be notified of emerging scams, fraud and other consumer threats as they arise, they can join one of the scam alert network. DOJ, Department of Justice, will keep user updated about important consumer information to educate and protect their friends, family, co-workers, and anyone else before they fall victim to scams and fraud. Do not click on any links embedded in phishing emails. They may contain viruses or spyware designed to steal users' personal information. Dispose of e-waste properly. Old computers, monitors and TVs cannot legally be put in the garbage. Recycle law was created to give anyone with less than 7 items to dispose of free access to electronics recycling. When disposing of e-waste, make sure user got their personal information. Even if user deletes their files, their old computer's information may be retrievable. Before shutting down for the last time, wipe the hard drive to completely remove their personal information. This important effort helps to keep toxins like lead and mercury out of landfills and thieves out of their personal files. Host and user authentication. In this video, we are going to see about host and user authentication. During the time of centralized computing, when users had to use terminals connected by means of serial links to mainframe or central computer. Authentication was centralized and there was only one place where it could be performed, that was the central host. Later on, when many computers were connected to the first networks and started communicating with one another using protocols such as TCP/IP, the authentication model started to change and became relatively decentralized. Users now needed an account on every host that they wanted to connect. Apart from interactive sessions, however, because of the small number of networked hosts, accessing resources that resided on one host from another host was a matter of a simple model of trust where authentication was not vital. The model of trust at that time was based on the Unix R** commands such as rsh and rlogin that provide for an authorization file with a list of remote users who are allowed equivalent access to the one local user has on a particular host. Authentication was not really involved. It was simple identification wherein the user ID of the requesting user as well as the name or IP address of the requesting host could be deduced by the request R** request. Authentication is divided into two categories such as centralized, decentralized. Centralized. The centralized authentication approach requires hosts to trust and follow the policies defined by a central authentication authority. This may be just one host or it may be a set of hosts that form a logical authentication authority. The authentication authority has an authentication database that can be used by all the hosts participating in the centralized authentication system. Decentralized. The decentralized authentication approach allows each network host to maintain its own user authentication database and policies. Unix hosts have their own and are independent from other hosts, etc/password file, and may potentially use PAM but will still maintain an independent database of users. Windows hosts maintain their own local security accounts manager (SAM) database and authenticate users against this database. Accounting management. In this video, we are going to see about accounting management. Accounting management lets user to measure the use of network services and determine cost to the service provider and charges to the customer for such use. In many enterprise networks, individual divisions or cost centers are changed for the use of network services. These are internal accounting issues rather than the actual cash transfers, but they are important to the participating users. The network manager needs to be able to track the use of network resources to ensure that the network is functioning efficiently and effectively. Since the network consists of components manufactured by multiple vendors, commonality in the definition and relationship of component attributes is needed. This is defined by Management Information Base (MIB). Some of the data acquisition has to be manual, but most data can and should be acquired in an automated mode. It also supports the determination of charges for services. This type of information helps a network manager to allocate the right kind of resources to users as well as plan for network growth. This type of management involves monitoring the login and log-off records and checking the network usage to determine a user's use of the network. Basic functions of accounting management are as given below. Track service or resource use, cost for services, accounting limit, usage quotas, audits, fraud reporting, combine costs from multiple resources, support for different accounting modes. Performance management. In this video, we are going to see about performance management. Performance management provides functions to evaluate and report on the behavior of telecommunication equipment and the effectiveness of the network or network element. Its role is to gather and analyze statistical data for the purpose of monitoring and correcting the behavior and effectiveness of the network elements, or other equipment, and to aid in planning, provisioning, maintenance, and quality measurement. Performance management includes the following functions: performance quality assurance, performance monitoring, performance management control, performance analysis. Performance quality assurance. Performance quality assurance includes quality measurements such as performance goals and assessment functions. Performance monitoring. This component involves the continuous collection of data concerning the performance of the network element. It includes the following functions: performance monitoring policy, network performance monitoring, event correlation and filtering, data aggregation and trending, circuit-specific data collection, traffic status, threshold crossing alert processing, trend analysis, performance monitoring data accumulation, detection, counting, storage, and reporting. Performance management control. This group includes the setting of thresholds and data analysis algorithms and the collection of performance data. It has no direct effect on the managed network. Performance analysis. The collected performance records may require additional processing and analysis to evaluate the entity's performance level. It includes recommendations for performance improvement, exception threshold policy, traffic forecasting, that is trending, performance summaries, that is per network and service and traffic specific, exception analysis per network and service and traffic specific, capacity analysis per network and service and traffic specific, performance characterization. ASN.1. In this video, we are going to see about ASN.1. ASN.1 is the acronym for Abstract Syntax Notation 1, a language for describing structured information, typically information intended to be conveyed across some interface or communication medium. ASN.1 has been standardized internationally. It is widely used in the specification of communication protocols. ASN.1 Encoding Rules. Data specified in the ASN.1 is not transmitted as such. Data is converted to standard format before transmission using certain rules. The sets of rules used to transform data specified in the ASN.1 language into a standard format before transmission is called ASN.1 encoding rules. The ASN.1 encoding rules currently standardized are Basic Encoding Rules (BER), Distinguished Encoding Rules (DER), Canonical Encoding Rules (CER), Packed Encoding Rules (PER), XML Encoding Rules (XER), Extended XML Encoding Rules (EXER). Developing ASN.1 applications. Developing ASN.1 applications is a simple process. This process is divided into 4 stages. Stage 1. Specification development. Stage 2. Translate. Syntax check and compile. Stage 3. Build. Writing application. Stage 4. Run. Putting the application to use. Stage 1. Specification development. In the first stage, the application designers have to decide on the types of messages that the final applications will need to send or exchange. Based on the message requirements, a new ASN.1 specification can be drafted or an existing one can be used. When drafting new ASN.1 specifications, it is helpful to decide on the encoding rules, for example, BER, DER, and PER, which will be used in sending messages. Stage 2. Translate. Syntax check and compile. Specifications, when being drafted, often contain typographical and other syntax errors which need to be corrected. Finding and correcting such errors in long and complex ASN.1 specification manually can be an arduous task. Quality ASN.1 compilers can pinpoint such errors, allowing the application developer to quickly resolve them. Stage 3. Build. Writing application. In the application code, we can use the data structures produced by the ASN.1 compiler much in the same way as we would use data structures written by us. Additionally, we can use vendor-provided runtime library functions, for example, the OSS-provided OSS encode function and OSS decode functions to encode, decode, and perform various other functions on application data. It is found that using such pre-prepared library functions will both cut down on the time needed to develop the application. This also increases application's final reliability and correctness. Stage 4. Run. Putting the application to use. Once application is debugged and tested, we can put it into use to send and receive ASN.1 encoded messages. SNMP. In this video, we are going to see about SNMP. The Simple Network Management Protocol (SNMP) was introduced in 1988 to meet the growing need for a standard for managing Internet protocol, that is IP devices. SNMP provides a standard for monitoring and controlling a network in vendor-independent manner. SNMP allows the retrieval and alteration of networking information maintained by hosts and routers attached to a network. A network administrator can use SNMP to diagnose and correct network problems from remote hosts. The structure of management information (SMI). Structure of Management Information (SMI) is a set of rules used to specify the format for defining managed objects. SMI describes the MIB naming tree that is used to identify managed objects and defines the branch of the MIB tree where SNMP managed objects reside. There are two versions of SMI. They are SMI v1, SMI v2. SMI v1 is defined by RFC 1155, RFC 1212, and RFC 1215. SMI v2 is defined by RFC 1902, RFC 1903, and RFC 1904. SMI data types. SMI data types are divided into three categories: simple types, application-wide types, simply constructed types. SMI data types. Simple: integer, octet strings, object IDs, bit strings. Application-wide: network addresses, counters, gauges, time ticks, opaque, integer, unsigned integer. Simply constructed: row, table. Management Information Base (MIB). Management Information Base (MIB) is an ASCII text file that describes SNMP network elements as a list of data objects. Think of it as a dictionary of the SNMP language. Every object referred to in an SNMP message must be listed in the MIB. MIB needs. SNMP Manager needs the MIB in order to process messages from its devices. Without the MIB, the message is just a meaningless string of numbers. SNMP Manager imports the MIB through a software function called compiling. Compiling converts the MIB from its raw ASCII format into a binary format the SNMP Manager can use. MIB file format. A MIB file is just ASCII text so that it can be viewed in any word processor or text editor such as Microsoft Notepad. Some manufacturers provide pre-compiled MIBs in binary format, but those are not readable. In such situation, raw ASCII version of the MIB file is required. If users want to view MIB files on a Windows PC, they have to get from vendor a DOS formatted version, or conversion utility software can be used to convert between text formats. The MIB is written in ASN.1 notation, that is Abstract Syntax Notation 1. ASN.1 is a standard notation maintained by the ISO, International Organization for Standardization, and used in everything from the World Wide Web to aviation control systems. For user purposes, there are only a few things to understand about ASN.1. It is human readable. It is specifically designed for communication between dissimilar computer systems, so it is the same for every machine. It is extensible, so it can be used for describing almost anything. Once a term is defined in ASN.1, it can be used as a building block for making other terms. This is very important for understanding MIB structure. MIB and OID. Each element in the MIB is given an object identifier, OID. An OID is a number that uniquely identifies an element in the SNMP universe. Each OID is associated with a human-readable text label. The value of the object identifier is a sequence of integers that refer to a particular traversal of the object tree. The OIDs identify the data objects that are the subjects of an SNMP message. When SNMP device sends a trap, it transmits a series of OIDs paired with their current values. Each object or characteristic has a unique object identifier OID consisting of numbers separated by decimal points, that is 1.3.6.4.1.2682.1. The root of the OID tree has no label. Currently, there are 3 children of the root: CCITT of 0, ISO of 1, and joint ISO CCITT of 2. The ISO node has many children, one of which is ORG3, is allocated for international organizations. Under ORG3 is the US Department of Defense DoD of 6, which has the child internet of 1. The name ISO ORG DoD Internet is a symbolic representation for the integer series 1.3.6.1. Both refer to the object identifier of the Internet subtree. In practice, 1.3.6.1 can simply be referred to as Internet. The terms ISO, ORG, DoD, Internet 1.3.6.1 and Internet are all different ways of identifying the same object. Internet has 4 children. The 4th child of Internet is called private and is given for private organizations. Under private, the first node is business enterprise. SNMP has 3 versions, namely SNMP v1, SNMP v2, SNMP v3. SNMP v1. In this video, we are going to see about SNMP v1. SNMP version 1, SNMP v1 is the initial implementation of the SNMP protocol. It is described in Request for Commands RFC 1157 and functions within the specifications of the Structure of Management Information SMI. SNMP v1 operates over protocols such as User Datagram Protocol UDP, OSI Connectionless Network Service CLNS, AppleTalk Datagram Delivery Protocol DDP, Novel Internet Packet Exchange IPX, Internet Protocol IP, SNMP v1 and Structure of Management Information SMI. The Structure of Management Information SMI defines the rules for describing management information using Abstract Syntax Notation 1 ASN.1. The SNMP v1 SMI is defined in Request for Commands RFC 1155. The SMI makes 3 key specifications: ASN.1 data types, SMI specific data types, SNMP MIB tables. SNMP v1 and ASN.1 data types. The SNMP v1 SMI specifies that all managed objects have a certain subset of Abstract Syntax Notation 1 ASN.1 data types associated with them. 3 ASN.1 data types are required: name, syntax, encoding. Name. The name serves as the object identifier, object ID. Syntax. The syntax defines the data type of the object, for example, integer or string. The SMI uses a subset of the ASN.1 syntax definitions. Encoding. The encoding data describes how information associated with a managed object is formatted as a series of data items for transmission over the network. SNMP MIB tables. The SNMP v1 SMI defines highly structured tables that are used to group instances of a tabular object, that is, an object that contains multiple variables. Tables are composed of 0 or more rows which are indexed in a way that allows SNMP to retrieve or alter an entire row with a single get next, or set command. SNMP v1 protocol operations. SNMP is a simple request-response protocol. The network management system issues a request and managed devices return responses. This behavior is implemented by using one of 5 protocol operations which are described below. Get request, get next request, set request, get response, trap. Get request used by the manager to request a specific MIB variable from the agent. Get next request used after the initial get request to retrieve the next object instance from a table or list. Set request used to set a MIB variable on an agent. Get response used by an agent to respond to a manager's get request or get next request message. Trap Trap used by an agent to transmit an unsolicited alarm to the manager. A trap message is sent when specific conditions occur, such as a change in the state of a device or component failure, or an agent initialization or restart. SNMP v3. In this video, we are going to see about SNMP v3. SNMP v3 is defined by RFC 3411, RFC 3418. SNMP v3 primarily added security and remote configuration enhancements to SNMP. SNMP v3 is the current standard version of SNMP. The IETF has designated SNMP v3 a full Internet standard, the highest maturity level for an RFC. SNMP v3 looks much different by introducing new textual conventions, concepts, and terminology and cryptographic security. SNMP v3 includes three important services: authentication, privacy, access control. SNMP v3 security model. SNMP v3 security model is developed to protect the following security threats. Security threats: modification of information. Description: contents modified by an unauthorized user. Masquerade: change of originating address by unauthorized user. Message stream modification: reordering, delay, or replay of messages. SNMP v3 provides important security features. Security features: message integrity. Description: ensure that a packet has not been tampered with in transit. Authentication: used to verify that the message is from a valid source. Encryption: encryption of packets to prevent snooping by an unauthorized person. SNMP v3 architecture introduced a user-based security model USM for message security and a view-based access control model VACM for access control. User-based security model USM. USM defines the elements of procedure for providing SNMP message level security. The USM protects the user against four threats, which are modification of information, masquerade, message stream modification, disclosure optionally. The USM uses MD5, that is message digest algorithm, and the secured hash algorithm to provide data integrity, to directly protect against data modification attacks, to indirectly provide data origin authentication, and to defend against masquerade attacks. View-based access control model VACM. VACM was proposed in RFC 2275 and it describes a view-based access control model for SNMP v3. It defines the elements of procedure for controlling access to management information. The VACM can simultaneously be associated in a single engine implementation with multiple message processing models and multiple security models. SNMP v3 applications. There are currently 5 SNMP v3 applications defined. This is summarized as given below. SNMP v3 applications description. Command generators creates SNMP messages. Command responders responds to SNMP messages. Notification originators sends trap or inform messages. Notification receivers receive and process trap or inform messages. Proxy forwarders forward messages between SNMP entity components. Network usage. In this video, we are going to see about network usage. Network performance can be measured in three complementary ways: by taking measurements on the network, assuming the network already exists, by conducting simulations, or by using analytical methods. Taking measurements is the only way of obtaining performance indicators that take into account all the real-world characteristics of the network. Computers can be used to write and execute programs that model the behavioral mechanisms of a system as a function of different variables. Analytical methods use the message queue theory and involve solution of equations that model different functional aspects of the network. Network management manages the network that transport information. However, from users' perspective, networks are meant to an end, namely to have access information across the networks. Thus, the user's needs require a total solution to manage the networks, system resources, and applications to run. Applications could be specific user application or general-purpose servers such as file servers, database servers, and DNS. Software products have since been developed to address such as system-wide solutions. An IT manager is interested in more than managing networks, systems, and applications. They would like to automate other functions such as backup of database and programs, downloading of software updates from a central location, and a host of other support functions. Network metrics. In this video, we are going to see about network metrics. Network management tools provide a variety of information to network operators and engineers through monitoring and measuring a variety of performance metrics. The most common metrics in the networking are availability, throughput, bandwidth utilization, latency or delay. Availability. Availability metrics assess how robust the network is, that is, the percentage of time the network is running without any problem impacting the availability of services. Loss and error. Loss and error metrics are indicative of the network congestion conditions and/or transmission errors and/or equipment malfunctioning. They usually measure the fraction of packets lost in a network due to buffer overflows or other reasons, or the fraction of error bits or packets. Delay. Delay metrics also assess the network congestion conditions or effect of routing changes. They measure the delay and delay variation of the packets transferred by a network. Bandwidth. Finally, bandwidth metrics assess the amount of data that a user can transfer through the network in a time unit, both dependent and independent from the existing network traffic. The metrics and information available from the different devices in the network are collected from the different devices within the network, and then these metrics are analyzed to prepare the performance reports of the operation of the computer system. Performance monitoring and reporting can be done either in real time or at periodic intervals. The operator of a system would typically like to see the performance metrics being displayed on a computer screen automatically, which colors or warning events identifying any components where there may be a performance impact. Network metrics concern the network administrator and monitor the behavior of the system during the service. Network quotas. In this video, we are going to see about network quotas. The quotas define the amount of network resources a customer is allowed to use under of its contracts. Quotas can be implemented as mandatory, in which case they are enforced, or as informational, which means compliance is simply monitored. Quota used on compressed volumes is calculated based on the uncompressed size of the stored files. Accounting management includes gathering of data about utilization of network resources, the setting of usage quotas using metrics, and the preparing of data for billing users for the use of the network. The network quota blocks access to all off-campus internet resources to users who have exceeded their bandwidth utilization quotas. The network quota was developed to protect the academic and research functions of network at Central Michigan University. Without the network quota or other network utilization protection mechanisms in place, the bandwidth available to these academic functions would be extremely limited. This has caused many problems in the past. In addition, the cost to provide this bandwidth has skyrocketed in recent years.